Double angle formulas. So what do you suppose we're going to do? We're going to take the angle and we're going to multiply it by 2, or double it, in other words. That's why you can see right there it says sine of 2 theta. We know that that means that basically would affect the period, right? If we looked at the graph, okay, it would happen twice in that amount of time. But what we're really looking at here is, again, we don't know the original angle, and we're going to basically double it and find out sine there. So let's say I was in the first quadrant and I double it. Where could that end up? Take any first quadrant angle you want, for example, maybe 20 degrees. You double that, where do you end up? Nope. Double 20, you're still in the first quadrant. But what if you take something like 60 and double it? Now you're in the second. Okay, keep that in mind. What we're actually going to do is, I'm going to show you where they come from. And then after that, you just, hopefully you can appreciate that and just refer to the actual formulas. All it is a direct application of the sum and difference identities. Because I could write this as sine of theta plus theta. Do you agree? Isn't that the same thing as 2 theta? I'm adding it to itself. Do I know what that self is? No, but I'm adding it to itself. And if you remember from the other day, remember the sign in sine stays the same with the sum and difference. And in that one, it says to take sine of the first one times cosine of the second one. And I'm showing you where the formulas come from here, because this one's simple enough. So it says plus right up here, and so plus. And then it says to take cosine of the first one and sine of the second one. The funny thing here is the first one and the second one are the same. So can we kind of put this together somehow? I mean, does this become, say, sine squared or anything like that? Did I take sine times sine anywhere here? No. But basically, I know now that sine of 2 theta is the same thing as, but you agree, how many of them do I have here? I have one of them. And do I have the exact same thing over here technically? So how many of them do I have? 2. Now you're wondering, why does that even make a difference? Well, that 2 is in a much more acceptable place right now. It's out front. So now I can know sine of the original and cosine of the original, and I can find sine of the doubled angle without knowing anything else. Okay? That right there is a formula that you're going to want to have written down somewhere, perhaps put a box around. Once we get to the application, it will make much more sense than what you're seeing right now. I'm showing you where the formulas are coming from. So sine of 2 theta really has just one formula that is readily used. Cosine, on the other hand, has quite a few, and you can use whichever one you want. I could just give you one and make you kind of work through it, but I've decided to give you several of them. So again, how do we start the other one? We said it's really just theta plus theta, right? Isn't that all it is? And if in sine, the sine stays the same, we know in cosine, it changes. Okay, again, that's that little memory device I gave you. So this one, I believe, has us taking cosine of the first one and taking it times cosine of the second one, correct? And what should I write down next to that? It's cosine of the first one, cosine of the second one, and the sign does change. It was plus, so now it is minus. And then it's sine of the first one, sine of the second one. Well, can we clean that one up? We cleaned up the last one fairly nice. Can we clean this one up at all? Yeah. Yep. So cosine of 2 theta, one of the options, and I could leave you with this one. I'm choosing not to. Is that? And then normally someone will say, but isn't that 1? No, that's cosine squared plus sine squared is 1, not minus. Okay, so that is one of your choices. And to speed things up for you, we'll give you a few other choices. I'm going to write in a different color that one identity I just talked about. You don't necessarily have to write it down if you don't want to. Hopefully that's the one that you have down fairly well. Sine squared plus cosine squared equals 1. Okay. What we're going to do is get kind of tricky. we're going to say, let's replace that. Just replace cosine squared. So what you have to do is you got to come up here and figure out what could I replace cosine squared with. In other words, get cosine squared by itself. And how do you get cosine squared by itself up in this red one here? Move the sine squared. And how do you move sine squared? Minus. So what I'm going to do is in red, I'm going to replace this with 1 minus sine squared. Again, please keep in mind I'm trying to actually help you here. You agree that is the same thing as saying cosine squared? Everybody's good with that? And then bring this other minus sine squared down here. Is that something we can clean up? Is that something I can clean up? No, it is not 1 minus sine to the fourth. Very close, though. It's minus 1 and minus another one. So minus 2 sine squared of theta. And if you stick with me long enough, you will see how that one will be beneficial. It's just going to save you time. Well, if we did it that way, I basically replaced cosine squared, right? Can I do the same thing and replace sine squared and do a very similar approach? You can. And I'll just give you that one because you can probably figure that out. I don't know where to write it, though. The other one is I do not expect you to memorize these. I will either let you write them down or give you a sheet that has them on there. I want to make sure you can apply them. These are your 3 options for cosine. My suggestion to you is use the one that will get you to the answer the quickest. And you'll figure that out. And I just want to review the sum and difference identities. That's why I like doing this. Everybody good? Okay, one last one. And then we can get to some problems. Tangent of theta plus theta. Let's see how many of you remember this one. It was just yesterday. Yep, tangent of first one plus tangent of second one. Does the sine actually stay on top, or does it switch? It stays on top. Yep, so tangent of the first one plus tangent of the second one. Oh, very good. 1 minus because it is plus here. So it's 1 minus. That'd be the opposite. Tangent of the first one times tangent of the second one. Very good. Well done. Now let's check your algebra skills one last time and see if you can clean this one up for me. Ah, 2 tangent on the top. Very good. Over. Nope. 1 minus tangent squared. Okay. All right, there, we got that taken care of. Now you've seen where they come from. We've reviewed sum and difference identities. We've done quite a bit already today. But we'll do more because we're so smart. Everybody got it down? Here it says cosine of some particular angle is the square root of 5 over 5. Well, I think it's fair to say that's not one of them on the unit circle that we know. It says, and theta terminates. What's that mean again? That's where it stops in the first quadrant. Okay. Then determine the exact value of each of the following. So it would like me to take that angle that I don't know, double it, and find cosine there. Interesting. Well, the first thing we should probably decide, well, we know cosine somewhere, correct? So why don't we go back? Now, isn't cosine the one that we had 3 options for? We already know cosine of theta. So of the 3 options, number 1 number 2, or number 3, which one is only asking for cosine? Number 3 is the one that's only asking for cosine. Does it need sine for number 3? Does it need sine for number 2? Yeah, does it need sine for number 1? You see what I mean? Use the one that's going to get you to the answer the quickest. Did I really need to give you these two? No. You could have done it otherwise. So the one we're going to use is right here, cosine of 2 theta. Yep, not going to do it. All right. Cosine of 2 theta equals 2 cosine squared minus 1. Now, what's that little trick with the square thing? What does that really mean again? That's really what squaring means. Just where mathematicians were very lazy and apparently don't want to put those parentheses in every time. Do we know cosine of theta in this problem? What is it? Square root of 5 over 5. So this right here, I'm going to completely replace with square root of 5 over 5. But then I'm going to do what to that square root of 5 over 5? Square it. And then what am I going to do? I'm going to subtract 1. Again, I'm looking for exact answers here. There are other ways with calculators we could do all of these problems. I'm choosing to have you do it differently. 2. Because of course order of operations says to do the powers first, so of course that's where we would go first. How about this square root of 5 that's sitting on top here? What do you get if you square that? Oh, we get 5. How about 5 squared? The one, oh, 25. Okay. Minus 1. Well, what should we probably do next then? I know what I would do. Write 5 over 25 as 1/5 minus 1. Are we all good so far? Well, what is 2 times 1/5? Is it 2/5? Yeah, it's that easy, right? Yeah. 2/5 minus 1, but how come I didn't write minus 1? Yeah, let's write it in a better form. What form of 1 is going to be helpful here? Oh, okay. Sounds good. Because now I have a common denominator. I wish I could impress upon you how long someone must have worked at this. Because did we know any of the angles in this problem? No. All of a sudden we doubled the angle, which we didn't even know, and found cosine at the new angle. I wish I could put that through there.